This is movie 5A, where we'll demonstrate another one-step problem using our idea strategy and pattern. You'll want to refer to your laminated sheet that has a periodic table on one side and the idea strategy on the other, together with the gray box of mole equalities. We'll be using our pattern. I want you to follow along in your student workbook. If you're confident in the steps, you can work ahead and see if you can get it right. If not, you can allow me to guide you to the correct answers, but make sure that you write down every step correctly so that you can end up with a correct calculation. Our first question is, what is the mass of 1.4 moles of NH4 3PO4, ammonium phosphate? First, we identify the given with units and write it down. What's the given in this question? It's the only number in the question, 1.4 moles, and we'll write that in the identify given box. Next, we draw a blank conversion factor. Now, enter the units from the given on the bottom. The units in the given are moles, so moles goes on the bottom. Now we're ready to answer the rest of the conversion factor using the known equality. For this, we'll need our gray box of mole equalities. If you look at the gray box, the number that always goes with moles is 1. So we'll put 1 on the bottom with moles. Now, 1 mole is in every equality, so we're not sure which one to use. How do we know? We look at the question. In the question, it is asking, what is the mass? Well, mass means grams, so we'll be using the equality that deals with grams, the third one right here. And it says 1 mole equals mm in a box grams. The mm stands for molar mass, and it's in a box to remind you that you'll need to look at the periodic table to figure it out. We'll be finding the mass of the ammonium phosphate, and this is pretty big, so we'll do it on the next page. Okay, anytime you have a compound that includes parentheses, you need to know that the number outside of the parentheses distributes to all the pieces inside. That means that we'll have 3 n's. Each n has a mass of 14 grams, so 14 times 3 is 42. Next, let's take a look at the h's. Okay, well, when the 3 distributes to the h with a 4, you multiply 3 times 4, and it tells you you have 12 h's. That's a lot of h's. 12 times 1 is 12, so the h accounts for 12 grams. Next, we have phosphorus, and there's only one. Phosphorus has a mass of 31 grams, so we just write 31. And last, we have 4 O's. Each O has a mass of 16 grams, and 16 times 4 is 64. Now we're ready to add up all these pieces, and when you add them all up, we get a molar mass of 149.0, which is the mass of that whole compound, ammonium phosphate. Now that we've calculated the molar mass, we can put that on the top, 149. Remember, we have to include our units, which were grams, so we'll put our grams right there next to the number. Okay, now we're at S, solve, if the desired units are on top. Well, what were our desired units again? They're asking for grams. So we look at our conversion factor. What do we have on top? We have grams, so we're ready to solve. We write down our fraction bar, and now we'll multiply the numbers across the top. 1.4 times 149.0 gives us 208.6. On the bottom, the only number we have is 1, so we'll put the 1 right here. And when you divide 208.6 divided by 1, you get 208.6. We're almost done, but we have to remember that you got to include units with all answers. So what units do we have? Well, the moles in the given and the mole on the bottom cancel out, and we're left with only grams. And because the question was asking us for the mass, which is grams, we know that grams will be the unit in our answer. All right, we've successfully answered that question, and we've got one more practice one to go, and you'll be able to work it with me in your student workbook.